Alrighty, let's see what we got today. Looks like it's gonna be medium. Minimize maximum pair sum in array. Pair sum AB is equal to A plus B. The pair sum of pair A comma B is equal to A plus B. The maximum pair sum is the largest pair sum in a list of pairs. For example, we have pairs 1, 5, 2, 3, 4, 4. The maximum would be 8, 4 plus 4, sure. Given an array nums of even length n, pair up the elements nums into n divided by 2 pairs such that each element has nums. Each element in nums is in exactly one pair, and the maximum pair sum is minimized. Return a minimize maximum pair sum after optimally pairing up all the elements. Really? Seems like you just pair them large to small, no? 5, 2, 3, 3. So it's 7. 6 to 2, 5 to 3, 4 to 4. So it's 8. Like, wouldn't you just sort this? Sort this and then just pair the biggest and smallest, second biggest, second smallest. And then just keep track of that. What is the, this is a high acceptance rate, so I'm gonna say that's probably what you should just do. I don't understand. Seems very close to an easy, maybe it's not quite easy somehow. Okay, so let's say n is the length of nums. So the answer is infinity to start with, and we're going to try and minimize it. So no, so we need to maximize. The maximum pair sum is minimized. So I think we need to actually keep track of the maximum pair sum here. So we need to start with the 0. For I in range n, let's say the pair is going to be nums at I plus nums at n minus I minus 1, I want to say. That's the pair sum there, and then answer equals max of answer. Actually, I think this should be that terminology is slightly slower than just using if statement. If pair is greater than answer, answer equals pair. Return answer. I don't understand if this is the correct answer. This is crazy. This is crazy. I think this is crazy. Trying to figure out if I consider this to be an easy in my mind, and therefore I'm surprised by it being medium, or if medium is the appropriate thing, because this, I mean, you do need a sort, and generally easy problems don't need a sort. I don't know. So I think this is close to easy difficulty. Maybe should be considered such, since the solution is simply to understand that sorting and combining kind of pairs from kind of from opposite sides, kind of opposite ends of the sorted array, kind of equally far from the ends at indices equally far from the ends is the optimal way to pair the values. Then keep track of the maximum pair. And this will be the minimum of possible out of all pairings. Yeah, I mean, there's really not much to say. If you're going to try and minimize the pairing, then you obviously should be using the smallest with the largest, right? You wouldn't be using the second smallest with the largest, or the largest with the second largest, right? So it has to be the smallest with the largest, and then if you remove those, then you do again the smallest with the largest of the remaining set, which ends up being just like the opposite ends of your sorted array. Anyway, time complexity is O of n log n to sort the array. After that, iterating over each element, each kind of indice to determine its pairing total is kind of O of n. Overall, O of n log n. Space complexity is O of 1, since sorting is in place and no extra space is needed. Cool.